Here we walk through an example of deployment and scoring that may be a little more realistic than some of our other deployment and scoring examples. We get into a few of the complexities that you might see in your environment. You may not be able to follow along with this one, so feel free to sit back and watch and listen. If you do want to inspect the processes more closely, this hotel app project dev should be available for download. We will begin by quickly going over the business understanding and data understanding and the data prep before moving into modeling within the development environment. After the processes are evaluated and tested, they get deployed. That happens by putting them into a versioned project. That project sits on AI Hub. Then the correct snapshot of that project is used to create an endpoint. That endpoint is available to be used with a REST post call. We can simulate the consuming application using this post REST operator. So let's walk through this from the beginning with a little more detail. We have data for customers on a hotel app booking service. And there's a requirement for an application that will predict churn or loyal propensity by region. In this case, region is the first digit of the postal code. Then we have some other attribute information. The data that can be provided to the model will look like this. Normally, you'd spend much more time on business understanding, but that's all we will cover here. Let's look a little more closely at the rest of the data and the data prep. To train the model, we need historical information on those customers. That is, we need to make sure we have data that has that churn or loyal attribute so that we can perform the training. This process simulates that call into the database or whatever data store we have with that full information. It looks a lot like that available scoring data. We can see that we've got a couple of customer attributes, including customer ID and the churn indicator, and then the rest of the attributes look like they match. So again, we're moving very quickly over data understanding and data preparation, and then into modeling. Here, we want to competitively compare a few different models and decide which one is the best, and then use it. We know that as the data and patterns change over time, we may need to retrain the model or even consider using a different type of model. So we will regularly compare these models to see if we are still using the best one. Here, the data prep dev process that we just inspected is called, and the data is sent into an optimize loop. The optimization happens over these three subprocesses, one for decision trees, one for naive Bayes, and one for gradient boosted trees. Whichever model performs the best will be selected. Then, for decision trees and gradient boosted trees, we optimize the parameters. For each of these models, no matter which one is the best, we annotate and store that model into the models folder. So here, we take that optimal parameter set from the optimization process, transpose it into annotations, and annotate the model with the timestamp. With naive Bayes, we merely annotate the timestamp. And with gradient boosted trees, we also annotate both that parameter set and the timestamp. If we hover over the models, F3 to hold the window in place, and load that metadata, and we can see each of the annotations that are currently there. Those attributes flagged for potential bias, the optimal parameters, and the date timestamp. Because this has multiple optimization loops, it can be a slow-running process. But if we run it now, we can update each of those three models. Again, for each of those three models, parameters are optimized, and that's done within cross-validation. And then performance is measured with area under the curve as the main criterion. Now the process has finished running, and it looks like the gradient boosted tree had the best overall AUC. If we sort by the optimized parameters for AUC, we can see the best results. On iteration 23, it created a model with 60 trees, and each had a maximal depth of 8, and we received an AUC of 0.852. We can look at some of the other performance details. We can look at the model itself, and we can see the max AUC for each of the other two models as well. So our models were updated, and this GBT model had the highest AUC out of all of them. Typically, we would take a little more care and consider other evaluation metrics as well. Perhaps we'd inspect costs and gains, and maybe compare even more than 3 different model types. For our purposes here, that's all the evaluation we will do. Next, we want to develop or test those processes that we want to push into production. That's the hotel app scoring process. Really, all it does is apply the model. First, it gets the production model wherever that is. It references it with a generic name, hotel app model. It doesn't specify whether it's a GBT that was saved on one date or a decision tree that was saved on another. It's a generic reference for the hotel app model in the same folder. If we look at this one, it's not the most recent GBT model that we decided was optimal. So let's update it. We can do it manually. We can go to that model and save it right over the existing hotel app model. Now, when this process calls that model, it will be calling the GBT model that we just decided was optimal. Next, data preparation. This process takes input data, and then it calls the hotel app scoring data prep process. First, let's look at what that input data could be. Under View, Show Panel, and Context. Anytime a process has input macros or data, the default values will probably be specified here. In this case, we can see the default for input 1 of the process is the postal code dataset. That's this one right here. It's very simple. It's just one column of all of the possible postal codes. That's the default input for this hotel app scoring process, and it gets sent directly to the hotel app scoring data prep process. Let's double click to step inside. That postal code data gets sent into the left side of a left join. This will have the effect of filtering down to all of the possible postal codes. The scoring data that we've already looked at is retrieved. A necessary change to the type is made, that left join, and that's it. Often, when you have processes that have inputs like this, you will also have some test harnesses to check for things like boundary conditions. In this case, we can specify the range of postal codes from that example set and check the scoring process. So let's run from examples 1 to 2. The postal codes in that example set are 2 and 7. We continue, and the model is successfully applied. What if we look at another boundary condition? We know that there are fewer than 12 examples in that set. So what if we try a range that doesn't exist? Well, we get an empty set of postal codes and an empty set of predictions. If this is the desired outcome in case of an empty set, then it looks like we are good to go. Once we are satisfied with our development and testing, they'll often be saved into a deployment candidate or staging location. So we don't want the dev or test processes at this stage. We'll just take those processes and objects that we need, Control-C to copy, Control-V to paste. We want to overwrite everything, and OK. Same thing, we can run a quick test based on the default inputs of the data prep, and again of the scoring. And now we get to move it to the project. So we connect to that project and get any updates that might already exist on the server version of that project. We use the git pull. We already have the latest snapshots. So we make our updates. We paste in and overwrite those processes and model. Again, if we hover over that model, we can see it is that recently updated GBT model. We might open up that process and run yet another test and verify that it still works. Now, we can create that snapshot and add it to AI Hub. Although we copied those processes in, there weren't any changes to those processes. So the only thing that's getting changed is that model we updated. So we add a comment and create the snapshot. Now on AI Hub, we can look at our snapshot history and we can see our most recent snapshot. Then let's go to Endpoints. We could create a new endpoint for that snapshot, or we may be able to edit the one in place. Let's try that first. Here, we can see that the snapshot is not updated automatically in this deployment, and it's using the previous snapshot. So let's update it here. There are a few other things here worth noting. For example, security is turned off. Anybody that has access to this server could call this endpoint. This is only recommended in very limited controlled situations. there are other options here. Now that we've got the snapshot, we could add another endpoint configuration, or see if we can update this one in place. First, we specify the process that will be called first, or the main process. That's our hotel app scoring process. We can modify the alias if needed. Next, parameter mapping. These would be URL query parameters for any macros that the process uses. Our process didn't use macros. It uses a data input. That's a little bit different. So there's nothing to do here. And then dependencies. We want to make sure that any data or other related processes or models are all included in the dependencies. It looks like there's nothing to update in that endpoint configuration, so it's time to save and redeploy. Next, we can see the URL, or there's a built-in little test harness that we could use. Instead of using that one, let's go back to RapidMiner Studio. This is where we have our own test harness for that endpoint. The request URL is here, and it has a JSON payload. This is the JSON structure of that postal code input data. So if we have one row where postal code is 3 and then run our process, we can see the JSON results, and for every row, the postal code is 3, or we could change it. Let's say there are 2 rows, 3 and 7, and run. And now we can see postal codes 3 and 7. So typically, there would be some other application making these RESTful calls and providing and consuming those JSON datasets. So in this demonstration, we quickly walked through the whole process of building out an application and deploying it on a RESTful endpoint so that it can be used in production. The details in your environment will probably be a little bit different, but the basics, developing the processes and training and validating the model and putting them into a production location so that they can be called, gets at the core of deployment and scoring.